Hello everyone, in this video we're going to learn how to solve the AP Calculus BC 2024 free response questions. Question number 1, A. Approximate C prime of phi using the average rate of change of C over the interval 3, 7. Show the work that leads to your answer and include units of measure. Right. So A. The average rate of change of f of s over the interval AB is given by the formula f prime of C equals f of B minus f of A over B minus A, where C is in the interval AB. Alright, so now we have the interval 3, 7, right? So we have C prime of phi equals, now phi right here, this is 3 right here, this is 7 right here, so phi is in the interval 3, 7, right? C of 3 is going to be 85, C of 7 is going to be 69. Alright, so we substitute over here, so it's going to be C7 minus C3 over 7 minus 3. C of 7, 69 minus 85 over 4. So it's going to be, alright, 69 minus 85 is going to be negative 16. Negative 16 divided by 4 is going to be negative 4. So negative 4 degrees Celsius per minute. Use a left remain sum with 3 sub-intervals indicated by the data in the table to approximate the value of interval from 0 to 12 ct of dt. Alright, so we look at this one. 3 interval and left remain sums. Alright, so the left remain sum, find the delta s right here. Delta s equals 3 for this guy, 4, and this guy, 5. Alright, now the left remain sum, which is C of 0 equals 100 right here, 85 and 69. Alright, so the interval from 0 to 12 ct dt equals 3 minus 0 f of 0 plus 7 minus 3 f of 3 plus 12 minus 7 f of 7. Alright, 3 minus 0 could be 3, f of 0 it could be 100, f of 3, 85, f of 7 it could be 69. So it's going to be 100 right here times 4, 8. Plus 4 times 85 plus 5 times 69. Alright. Three times 100 is going to be 300 plus 4 times 85 plus 5 times 69. It's going to be 985. degrees Celsius. Alright, next one. Interpret the meaning of 1 over 12 integral from 0 to 12 cities dt in the context of the problem. Alright, so we're going to use the average values of a function. 1 over 12 integral from 0 to 12 ct dt is going to be equal to 1 over 12 minus 0 integral from 0 to 12 ct dt. Alright, so this is the average temperatures of the coffee in degrees Celsius over the interval 0 12. Alright, let's move on to question C. For T from 12 to 20, the rate of change of the temperatures of the coffee is modeled by C prime of T equals negative 24.55 times e to the 0.01 t over t, where C prime t is measured in degrees Celsius per minute. Find the temperature of the coffee at time t equals 20. So question C, we need to use the fundamental theorem of calculus. The fundamental theorem of calculus says, if a function f is continuous on the closed interval ab, and f is an antiderivative of f on the interval ab, then the interval from a to b of f of s ds equals f of b minus f of a. Alright, so we look at this one right here. C prime is for this, right? So C prime is the derivative of CT. T equal 20 right here, right? 12 and 20. Alright, so we have the integral from C prime t dt equals C20 minus C12. So we have C20 equals the integral from 12 to 20 C prime t dt plus C12. Now we just substitute values, right? The integral of this one is going to be this guy right here. 12, 20, negative 24.55 times e to the 0.01 t over t plus C12. C12 equals 55 right here. Alright, alpha window, pick number 4. Alright, so this is 12, this is 20, this guy negative 24.55 times e to the 0.01 t, which means s right here, over s, right? This is ds. Enter. It's going to be negative 14.670 14.08. So negative 14.6708 plus 55. So plus 55, 40.3292. So it's approximate 40.3292 degree Celsius. Alright, let's move on to question D. For the model defined in part C, it can be shown that C double prime T equals this one for T from 12 to 20. Determine whether the temperature of the coffee is changing at decreasing rate or an increasing rate. Alright, so we have the second derivative right here. Alright, so this guy always positive. Right, this guy right here positive because T is from 12 to 20. You substitute over here any values between 12 and 20. This guy always positive. Right, this guy positive. So C double prime always positive. C double prime positive. It tells us that the temperatures of the coffee is changing at an increasing rate. In other words, the rate of change of C prime T is increasing. Alright, so question D right here, you just copy the whole thing there. C prime of T is greater than 0 for T in the interval 12 to 20. It tells us that the temperature of the coffee is changes at an increasing rate. Let's move on to question 2. A particle moving along a curve in the xy plane has position s of t, y of t, at time t seconds, where s of t and y of t are measured in centimeters. It's known that s prime of t is equals 8t minus t squared, and y prime of t equals negative t plus square root of t to the 1.2 plus 20. At time t equal to seconds, the particle is at the point 3, 6. Find the speed of the particle at time t equal to seconds. Show the setup for your calculations. Alright, so basically, the formula for the speed is going to be Vt equals square root of ds over dt square plus dy over dt square. Alright, ds over dt is going to be right here, and dy over dt is going to be right here. Alright, so we just substitute values, so it's going to be a t minus t square altogether square plus negative t plus square root of t to the 1.2 plus 20 altogether square. And we need to evaluate this expression when t equals 2. Alright. Now we're going to bring up the calculator. So the first one, we hit y equals y1, we just input s prime t right here, this guy right here. So we just input 8 s minus s square. Alright, so the second equation is going to be this guy right here. So it could be negative s plus square root s to the 1.2 plus 20. Alright, so that's it. Now we just exit this one. Alright, so we just hit second square root right here. So we don't need to input this one anymore. We already have y1, y2 right there. So we just hit parentheses var y function y1 and then parentheses 2 close parentheses, one more parenthesis, and then square. This is to calculate the value of this expression when t equals 2. Alright, so we add the same thing. We put parentheses var y function y2. Alright, and parentheses 2 close parenthesis one more times and then square. Alright, hit enter and the answer is 12.305. Alright, so it could be approximately 12.305 centimeter per second. Alright, question B. Find the total distance traveled by the particle over the time interval 0, 2. Alright, so here's the keyword total distance. Alright, so it's gonna be interval from 0 to 2. Absolute value of v t dt. Alright, so it's gonna be interval from 0 to 2. Absolute value of square root s prime t square plus y prime t square dt. Alright, so we just input this expression. So it's going to be interval from 0 to 2. Absolute value of square root of a t minus t square plus negative t plus square root of t to the 1.2 plus 20 altogether square dt. Alright, so we're gonna bring up the calculator. We hit alpha window number 4. Alright, interval from 0 to 2. Alright, now alpha window again, hit absolute value which is number 1. And then second square. Parenthesis var y function y1 close parenthesis square plus parenthesis var y function y2 close parenthesis square. Go outside ds. So put s right here and hit enter. Alright, so the answer must be around 15.902. So it's gonna be 15.902 centimeter. Alright, question C. Find the y-coordinate of the position of the particle at the time t equals 0. Alright, so y-coordinate, look at this one only. Alright, and we need to use the fundamental theorem of calculus. So we have the interval from 0 to 2 of y prime of t dt equals y of 2 minus y of 0. Alright, so we have y of 0 equals y of 2 minus the interval from 0 to 2 y prime of t dt. Alright, so y of 2 given right here. t equal to, alright, the particle s sits right here, so it's gonna be sit minus interval from 0 to y prime t, which is this guy right here, so it's gonna be parenthesis negative t plus square root of t to the 1.2 plus 20 close parenthesis dt. Alright, now we bring up the calculator. So we hit sit minus interval, so alpha window number for interval from 0 to 2. Alright, parenthesis. Now hit var y var function. In this situation we hit y2 because this is for y prime t, so enter, go outside, you want to put ds and then hit enter. The answer is going to be negative 1.174. Now let's move on to question D. For t between 2 and 8, the particle remains in the first quadrant. Find all times t in the interval 2 to 8 when the particle is moving toward the s-axis. Alright, here's the keyword, remain in the first quadrant. So we just draw this diagram. Alright, so this is y and this is s. Now this is the first quadrant, this is the second one, this is the third one, and this is the fourth one. Alright, so the particle here. Alright, so in the first quadrant we know that s and y always positive. Now because the particle move toward the s-axis, which is this will be negative direction. So this could be negative direction. Alright, we know that this is positive right here. Alright, so negative direction, which means y prime should be less than 0. Right? So now we just graph this one. Now we're gonna bring up the calculator. So we hit y equals. Now because we only need y2 right here, which is y prime of t, right? We don't need y1, which is s prime of t. Now you have two options. You either freeze y1 or you delete it. Alright, if you want to delete it, go to the right hand side and hit clear. Or if you want to freeze it for later use, you just move your cursor to the middle of the equal sign right here. You hit enter, and it's not showing up anymore. Now the graph does not show up properly, so you need to adjust the window, right? So right here the window range should be 2 to 8 because the domain given is 2 to 8, so it could be 2 and 8 right here. The scale should be 1, good. Y means you just put negative 5 and 5 right here, okay? So you're gonna hit graph, it's gonna be right here. Now you need to find the intersection between the graph and the s-axis, which is the 0. Alright, so you're gonna hit second trace. Alright, hit number 2 right here, 0. Alright, now you move your cursor to the left of 0, you hit enter. You move your cursor to the right of 0, you hit enter. Now you move your cursor inside of these two bounds, you hit enter. The answer should be 5.222. Alright, so t must be between 5.222 and 8. Now look at this one right here. We have t from 2 to 8 and we have equal sign right here. So we need to include 8. Or you can write this one as an interval notation, which is t belong to parenthesis 5.222 and H right here, you put a bracket. Let's move on to question number 3. The depth of seawater at a location can be modeled by the function h that satisfies the differential equation dh over dt equals 1 half h minus 1 times cosine t over 2, where ht is measured in feet and t is measured in hours afternoon t equals 0. It's known that h of 0 is equal 4. A portion of the slope field for the differential equation is provided scatter solution curve y equal ht through the point 0, 4. Alright, so point 0, 4 is going to be right here. Alright, so now we need to scatter solution curve. Right, so it's going to be like this. Alright, let's move on to question B. For t's between 0 and 5, it can be shown that ht is greater than 1. Find the value of t's for t from 0 to 5 h, which h has a critical point. The critical points occur when h prime of t equals 0. Or h prime of t is undefined. Alright, so the h over dt is going to be right here. So we have 1 half h minus 1 times cosine t over 2 equals 0. Now, because h is greater than 1, right? H greater than 1, which means h minus 1 greater than 0. Right, so we have this guy right here greater than 0. Right, so this guy multiplied by this guy equals 0, only cosine t over 2 greater than 0. But 0 is going to be cosine pi over 2. So we have t over 2 equals pi over 2 plus k I. For k is the integer. Right? Because we look at the unit circle right here. So this is cosine and this is sine. Alright. Cosine equals 0 when the angle is pi over 2, 3 pi over 2. Alright, so pi over 2 at k pi. K equals 0, you get pi over 2. K equals 1, you get 3 pi over 2. And then 5 pi over 2. Now we multiply both sides by 2, so t equals pi plus k 2 pi. Now t equals k equals 0, it's going to be pi. K equals 1, it's going to be 3 pi. K equals 2, it's going to be 5 pi, etc. Now, we look at the domain right here. Domain t is from 0 to pi. Alright, so t is from 0 to pi, only this one satisfies the domain, right? Because this guy is going to be 3.14 something. Alright, so only t equals 5 satisfy the domain. T is from 0 to 5. Determine whether the critical point corresponds to a relative minimum, relative maximum, or neither a relative minimum nor a relative maximum of the depth of seawater at the location. Alright, so Alright, so recall. So this is the value of t over the interval a, b. Now, suppose we have t1. This is f prime of t, and this is f of t. Alright, this is a critical point makes f prime of t equals 0. So, suppose this is negative, this is positive. F prime of t is changing from negative to positive. This is going down, this is going up. We get the relative minimum. Now, similarly, we have the second one. This is t, this is f prime of t, and this is f of t. A, B, we have t1 right here, 0. Now f prime of t changes from positive to negative. This guy going up, this guy going down. So we get the relative maximum. Alright, so we have the table. This is t, this is h prime of t, and this is h of t. This is 0, 5, and this is pi. So since pi is the critical point, so this guy must be equal to 0. Alright, now we're gonna put a value t equals 2 in this interval. So we substitute into h prime of t. So we have h prime of t is gonna be right here. It's gonna be 1/2 of h minus 1 times cosine 2 over 2. Alright, so because t is always greater than 1, so this guy always positive. So cosine 2 over 2, it could be cosine 1 greater than 0. So h prime of t is always greater than 0 on the interval 0 to pi. So this guy should be positive. This guy should be negative. So this guy's going up. This guy's going down. And this is relative maximum. Alright, let's move on to question C. Use separation of variables to find y equals h of t. The particular solution to the differential equation dh over dt is equals 1/2 h minus 1 cosine t over 2 with initial condition dh over dt equals 1/2 h minus 1 cosine t over 2. Alright, so we have dh over h minus 1 equals 1/2 cosine t over 2. dt. Alright, now we're going to integrate both sides. 1 over h minus 1 dh equals 1/2 cosine t over 2 dt. Now integrate this one is going to be natural log of absolute value of h minus 1 equals, now recall, the antiderivative of cosine of AS plus B ds is going to be 1 over A sine AS plus B plus C right here. Alright, so this guy turns out to be 1 over 1/2. Alright, so we have 1/2 right here times 1 over 1/2 sine t over 2 plus c. Alright, now 1/2 cancel out. Now, because h, remember, we have the condition right here, h of t is greater than 1, right, for every single t between 0 and 5. Alright, so h of t is greater than 1, which means h minus 1 greater than 0. So we need to remove the absolute value of this one. So it turns out to be natural log of h minus 1 equals sine t over 2 plus c. Alright, now we have the initial condition. It's going to be h of 0 equals 4. Alright, so we have natural log of 4 minus 1 equals sine 0 divided by 2 plus c. Alright, so c equals natural log of 3. Now substitute back over here, so we have natural log of h minus 1 equals sine t over 2 plus natural log of 3. Alright, so h minus 1 equals e to the sine t over 2 plus natural log of 3. Alright, but this guy right here, we just separate them, so e to the sine t over 2 times e to the natural log of 3, right? But e to natural log of 3 is going to be 3, so it's going to be 3 times e to the sine t over 2. Alright, so finally h equals 3 times e to the sine t over 2 plus 1. Let's move on to question number 4. Alright, question A. The function g is defined by g of s equals the integral from 0 to s f of t dt. We need to find the value of g of negative 6, g of 4, and g of 6. So we have over here g of negative 6 is going to be integral from 0 to negative 6 f of t dt. Alright, now we just change the bounds right here and we change the size, so it could be integral from negative 6 to 0 f of t dt. Alright, so we look at this one, negative 6 right here, 0 right here. So the integral from negative 6 to 0 f of t dt is the error of this region right here. Alright, but we have it 12 right here, so it could be negative 12. Next one, g4 equals the integral from 0 to 4 f of t dt. Alright, from 0 to 4 it's going to be right here. This is actually the error of this triangle right here. Alright, so equals 1/2 base times height. Right, base equals 4 right here, and height is equal to 2. So it's going to be 1/2 4 times 2. So the answer should be 4. Now, g of 6 is going to be integral from 0 to 6 f of t dt. Alright, 0 to 6 we have 2 regions right here. The triangle on the top and the triangle on the bottom right here. So it's going to be integral from 0 to 4 f of t dt plus the integral from 4 to 6 f of t dt. Alright, so integral from 0 to 4 is going to be 4. Integral from 4 to 6. Alright, because this guy is below the x-axis, so it should be subtraction. Now we need to find the error of this one, so it's going to be the base equal 2. And the height should be 1. So it could be 1/2 1 times 2. So it could be 3. Now let's move on to question B. For the function g is defined in part A. Find all values of s in the interval from 0 to 6 at which the graph of g has critical point. Okay, so we know that the critical points occur when g prime of s equals 0 or g prime of s is undefined. Now we have g of s is the integral from 0 to s of f of t dt. So we're going to take the derivative of this one. So g prime of s is going to be f of s. Right? We just substitute s over here. When we take the derivative, we just substitute s over here. So we have f of s right here. Alright, so g prime of s equals 0. Then f of s must be equals 0. Alright, so we have the domain 0 to 6. So it's going to be from here to here. F of s equals 0 when s equals 4 right here. Alright, so s equals 4. The function h is defined by h of s equals integral from -6 to s f prime of t dt. Right, so we have h of s equals -6 to s f prime t dt. Find the value of s of 6, h prime of 6, h double prime of 6. H of 6 equals the integral from -6 to 6 f prime of t dt. So by fundamental theorem of calculus, we have f of 6 minus f of -6. Right, f of 6 right here equals -1. F of -6 equals 0.5 minus 0.5. So it's going to be -1.5. Next one, h prime of 6. So from this one, we have h of s equals f of s. Then h prime of s equals f prime of s. Now h prime of 6 equals f prime of 6. F prime of 6 is the slope of the tangent line of f of s at s equals 6. Alright, so we have h prime of 6 equals f prime of 6 equals right? Rise over run. Evaluated at s equals 6. So we look at this one. From 0 to 6 right here. This is the linear function. So we need to calculate the slope of this one. So rise equals 1. Run equals -2. Right, so it could be -1/2. H double prime. So H double prime of 6 equals F double prime of 6. Now we look at this one right here. From 0 to 6 right here, this is the linear function. So suppose this one has the function f of s equals a s plus b. Now take the first derivative, f of s equals a. Now the second derivative of this one, a derivative of the constant should be 0. Alright, so go back over here. This is a linear function. So the second derivative s equals 0. Because this is a straight line. In the interval 0 to 7. Let's move on to question 5. The function f is twice differentiable for all s with f of 0 equals 0. Values of f prime, the derivative of f, are given in the table for selected values of s. Question A. For all s greater than or equal to 0, the function h is defined by h of s. The interval from 0 to s, square root of 1 plus f prime of t squared dt. Find the value of h prime of pi. Alright, so question A right here. So basically, h of s equals the interval from 0 to s, square root of 1 plus f prime of t squared. Alright, take the derivative both sides, so it turns out to be h prime of s equals square root of 1 plus f prime of s squared. Alright, now we need to calculate h prime of pi. So we just substitute pi. So it turns out to be h prime of pi. It's going to be square root of 1 plus f prime of pi squared. Now we look at the table right here. F prime of pi. F prime right here, pi right here. So it's going to be 6 right here. So 6 squared equals 36. 36 plus 1 is going to be 37. So the answer must be square root of 37. Alright, question B. What information does this guy provide about the graph of f? This is actually the formula of the arclength of f. Alright, so this formula is the arclength of the function f on the interval 0 pi, which is this guy right here. Now let's move on to question C. Use Euler method starting at s equals 0 with 2 steps of equal sign to approximate f of 2 pi. So we have the Euler formula. It's going to be f of s1 equals f of s0 plus f prime of s0 multiplied by h, where h is the step size. So we start as S0, S1, and S2 right here. Alright, S0 is going to be 0 is given right here. Alright, S1, S2 is going to be 2 pi right here. And since we have two steps of equal size, so the middle one right here should be pi. Alright, so we need to calculate f of S1 right here. Alright, so we have f pi equals f of 0 plus f of 0 times pi minus 0. Alright, so substitute f of 0 is going to be right here, equals 0. Right, so 0 plus f prime of 0, f prime of 0 is going to be 5. So we have 5 times pi minus 0 is going to be pi. So it could be 5 pi. Now f of 2 pi is going to be f of pi plus f prime of pi times 2 pi minus pi. Alright, substitute f of pi is going to be 5 pi right here. Plus f prime of pi is going to be on the table right here. It's going to be 6. 2 pi minus pi is going to be pi. And then you add them up, it's going to be 11 pi. And this is the answer for question C. Alright, let's move on to question D. Find the integral of t plus 5 cosine t over 4 dt. Alright, so this is very simple. Just use the integration by part. Alright, so question D. The integral for t plus 5 cosine t over 4 dt. Alright, so you just let u equals t plus 5. So we have du is going to be dt. Right? dv equals cosine t over 4 dt. And then v is going to be, alright, so we have the formula, recall. Right? To integrate cosine of as plus b ds is going to be 1 over a sine of as plus b plus the constant. Alright, so keep that in mind. 1 over 4, it should be 4. So 4 sine t over 4. Alright. So the formula for the integral by part is going to be dv equals u times v minus the integral of v du. Alright, so we just this guy u, this guy dv. Alright, so it turns out to be u times v, so it can be t plus 5 times 4, I bring 4 to the front, sine t over 4 minus v du, 4, I bring it 4 to the front, so it's sine t over 4 dt. Alright, so I need to calculate this one. So this guy right here, Right, we have the second formula. Right, want to integrate this one. Sine AS plus B dx is going to be negative 1 over A cosine AS plus B plus the constant C. Alright, so it turns out to be 4t plus 5 sine t over 4. Alright, this one when you integrate it turns out to be negative side, so negative turns out to be positive. Alright, 1 over 4, which is 4 times 4 is going to be 16, so 16 cosine t over 4 plus c. Alright, and this is the answer for question D. Let's move on to question 6. The Maclaurin series for a function f is given by this guy and converges to f of s for all s in the interval of conversion. It can be shown that the Maclaurin series for f has a radius of convergence z. Determine whether the Maclaurin series for f converges or diverges at s equals z. Alright, so basically you just have to do set over here. Alright, so we have question A. The sum and goes from 1 to infinity. N plus 1 times 6 to the n over n squared times 6 to the n. Alright, now this guy and this guy cancel out, so we get the sum and goes from 1 to infinity n plus 1 over n squared. Now whenever you see the rational function, alright, 9 out of 10, we're going to use the limit comparison test. Alright, so basically when n approaches infinity, you have n plus 1 over n squared. Alright, you see that n much larger than 1, so you just ignore 1. So it's going to be n over n squared. It's going to be 1 over n. So we compare this guy and this guy. Alright, so we have limit when n approaches infinity of n plus 1 over n squared over 1 over n. Alright, so we just flip this one. It turns out to be limit n approaches infinity n plus 1 over n squared times n over 1. Alright, so it turns out to be limit n approaches infinity of n plus 1 over n. Alright. Now when n approaches infinity, this guy much less than 1, so you have limit n approaches infinity. You just ignore 1, so it's going to be n over n, so it's going to be 1 greater than 0. This guy's harmonic series. Since the harmonic series diverges by the p-series test because p equals 1, which is less than or equal to 1. So this one is divergent at s equals 6. Alright, let's move on to question B. It can be shown that f of negative 3 equals the sum n goes from 1 to infinity n plus 1 times negative 3 to the n squared times 6 to the n equals this guy, and that the first three terms of this series sum to this guy. Show that f of negative 3 subtract s3, absolute value of this guy less than 1 over 50. So this is actually the error bound. Alright, and this is alternating series. So, question B. So, since f of negative 3 equals this one, we substitute negative 3 over here, so it's going to be sum and go from 1 to infinity n plus 1 negative 3 to the n over n squared times 6 to the n equals the sum and go from 1 to infinity n plus 1 over n squared times negative 1/2 to the n is an alternating series that is convergent. Because the radius of convergence is s1 equals 6. And absolute value of s less than 6. Or you can write negative 6 less than s less than 6. Now we have s2 equals negative 3. So s2 equals negative 3, which is in this interval. So this guy in the negative 6 to 6 interval right here. Alright. So now we have the error about it's going to be absolute value of f of negative 3 subtract s3 less than the fourth term, which is you substitute for into this sequence right here. So it could be 4 plus 1 over 4 square times negative 1/2 to the 4, and then it's going to be 5 over 16 times 1 over 16. It's going to be 5 over 256. Alright, this guy less than 5 over 250. And if you simplify, it turns out to be 1 over 50. Alright, and then we just prove right here, we just prove it. Alright, let's move on to question C. Find the general terms of the Maclaurin series for f prime, the derivative of f. Find the radius of convergence of the Maclaurin series for f prime. Okay, so we have f is going to be this guy right here. Now f prime, we just check the derivative of this guy. Alright, so we have f prime of s is going to be, this guy is constant, this guy is constant, only this guy variable right here. So we have the formula s and derivative is going to be n times s n minus 1. Alright, so we apply this guy. Alright, so we just rewrite everything. The sum when s goes from 1 to infinity, n times n plus 1 times s to the n minus 1 over n squared times 6 to the n. Alright, now we just simplify this guy, so it turns out to be n equals 1 to infinity. Right, n and n squared right here we cancel out, so it's going to be n plus 1 times s to the n minus 1 over n times 6 to the n. Alright, now since the original function right here has the radius of 6, and then its derivative must have the same radius of conversion, so which is s equals 6. Alright, so s equals 6. Now we can check to see if it's right. We can use the limit comparison test. Alright, so let's check limit when n approaches infinity. Now f prime of s is going to be this one, right? So 1 unit above this one should be n plus 1, right? So we're going to do this guy. Alright, so we put it on the bottom. N plus 1 times s to the n minus 1 over n times 6 to the n. Now on the top you need to, now we just replace every single n right here with n plus 1. So this guy right here turns out to be n plus 2 times this guy right here turns out to be s to the n over this guy right here turns out to be n plus 1, and then this guy turns out to be 6 to the n plus 1. Alright, equals limit when n approaches infinity right here. Now we just flip this guy, so it turns out to be n plus 2 times s to the n over n plus 1 times 6 to the n plus 1. I just write 6 to the n times 6. Alright, now turn this guy into the multiplication. You need to flip this guy, so it turns out to be n times 6 to the n over n plus 1 times this guy turns out to be s to the n divided by s. So s I just bring it to the top, so it turns out to be ns right here. Alright, so now we're going to simplify. S to the n and s to the n gone. 6 to the n, 6 to the n gone. So the top should be limit when n approaches infinity, n plus 2 times n s over n plus 1 square times 6. Alright, oh, I forgot to put the absolute value. At this time, we have two different ways to calculate this one. Now, when n approaches infinity, so n right here much larger than 2. So we just ignore 2. Alright? We just ignore 1. So it turns out to be limit when n approaches infinity. The top should be absolute value of n squared times s. The bottom should be n squared times 6. Alright, and we simplify this one. It turns out to be absolute value of s over 6. Right, this guy gone. And then this guy less than 1. And then we have absolute value of s less than 6. Alright, we're done. This is called relative float rate. Alright, now the second method right here, we just expand this one. Alright, so limit when n approaches infinity. Right, I just expand this one, so it turns out to be n squared plus 2n times s over n squared plus 2n plus 1 times 6. Alright, absolute value. Alright, so I just factor n squared out, so it could be limit n approaches infinity. Factor n squared out, so it could be n squared parenthesis 1 plus 2 over n times s over 6n squared. It's going to be 1 plus 2 over n plus 1 over n squared. Alright, when n approaches infinity, this guy 0, this guy 0, this guy 0, this guy cancel out. So the top should be absolute value of s. The bottom should be 6. This guy less than 1, or absolute value of s less than 6. We're done. Alright? Alright. So keep in mind, this one you don't need to show it on the test. But, alright, just want to make sure you understand this one, so I just get it done. Alright, you just do like this and it's fine. Alright. Now, the last question, move on to question D. Let GS equals this guy. Use the ratio test to determine the radius of convergence of the Maclaurin series for G. Alright, so this is very simple. Alright, this is similar to what we just did right here. Alright, so G of S equals, so it's going to be sum n goes from 1 to infinity n plus 1 times s to the 2n over n squared times 3n. Now by the limit comparison test, it's going to be limit, right, absolute value of this guy, right. The bottom one, we're going to put this one, so keep that in mind. N plus 1 times s to the 2n over n squared times 3 to the n. Alright, right here, make sure n is going to be 1 unit that greater than this one. Okay, so we just replace n with n plus 1. Alright, so right here n plus 1 over here, plus 1 is going to be n plus 2. This is s to the 2n plus 2. Alright, a lot of students make mistake. Alright, you replace n with n plus 1, so it's going to be s to the 2 parentheses n plus 1. Alright, so it turns out to be n, distribute this one, it turns out to be s to the 2n plus 2. Alright, still and mostly do like this, 2n plus 1, that's wrong, okay, so be careful. Alright, over n plus 1 square times 3 to the n plus 1. Alright, now we just simplify this one, so it's going to be limit when n approaches infinity, absolute value of this guy. Alright, this is a division. We just turn this one into multiplication by flipping the denominator, so it turns out to be n plus 2 times s to the 2n plus 2 over n plus 1 square times 3 to the n plus 1 multiply n square times 3 to the n over n plus 1 times s to the 2n. Alright, equals limit when n approaches infinity. Alright, this one we just simplify. Now s to the 2n I just write s to the 2n times s squared. Alright, now 3 to the n plus 1 I just write 3 to the n times 3. Alright, okay, so we just simplify this guy. S to the 2n right here and s to the 2n right here cancel out. 3 to the n and 3 to the n cancel out. So the top should be n squared right here times n squared times n plus 2. Alright, times s squared right here. Over the bottom, it should be n plus 1 squared times n plus 1. So it could be n plus 1 cubed. Alright, times 3 right here. Alright, don't forget to put the absolute value right here. Alright, so in order to calculate this limit, look at this one when n approaches infinity. So n much larger than 2 right here. So we just ignore this guy. Alright, so the top should be limit n approaches infinity, absolute value of n squared times n is going to be n cubed times s squared over this is n cubed times 3 absolute value. Now we just simplify n cube's gone. The absolute value of s squared over 3. This guy must be less than 1. So absolute value of s squared less than 3. Alright, so we take square root, so it's going to be s equals root 3. This is the registers of convergence of the series. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.